So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic motion. So guys, this video will be about the laws of motion. So in short to stay till the end of this video. Let's go ahead and start with the first question here. It says, when a lightweight body and a massive body are acted upon by the same force for the same period of time, the A massive body builds up a higher velocity. B. Lighter body has a higher momentum. C. Momenta of both bodies remain the same. D. Massive body has a higher momentum. So guys, the answer to this question is option C here. The momenta of both bodies remain the same. So let's go ahead and consider the next question, guys. So the next question we have here is question number 2. It says, a body of mass 2 kg is released from rest on a smooth plane inclined at an angle of 60 degrees to the horizontal. Calculate the acceleration of the body down the plane. So guys, here, in order for us to calculate the acceleration, we are going to use the formula g sine theta. So the g here is 10 meters per second squared, and then sine theta is sine 60. So when we do g sine theta, we are going to have 8.7 meters per second squared, and that's option D here. Option D is the acceleration. So let's go ahead and consider the next question, guys. So here is it here, question number 3. It says, a ball of mass 5 kg hits a smooth vertical wall, normally with a speed of 2 meters per second, and rebounds with the same speed. Determine the impulse experienced by the ball. Alright, so guys, for this here, we're going to recall that impulse Ft is equal to mass times change in velocity here. So that's mass times v minus u. So guys, if we solve using this, we are going to have that the impulse Ft is equal to the mass 5 kg into the velocity v here is actually 2 meters per second here minus. Alright, so guys, since there is a rebound with the same speed, that's going to be like a negative 2. So that will be 2 minus negative 2. So that's 2 plus 2, guys, here. So in this case, we'll have 5 into 4, and that's 20. So option C is the answer to this question, 20 kilogram meter per second. Alright, so guys, let's go ahead and consider the next question. Alright, so guys, the next question we have here is question number 4. It says, a 60 kg man stands on the weighing balance in an elevator, accelerating upwards at 5 meters per second squared. Determine the reading on the scale. So guys, in order for us to calculate the reading on the scale here, the scale reading will be equal to the mass into the acceleration due to gravity plus the linear acceleration here. So the mass is 60 kg. The acceleration due to gravity g is 10 meters per second squared, and the linear acceleration here is 5 meters per second squared. So 60 into 10 plus 5 is actually 60 into 15, and that's 900 Newton. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So the next question here is question number 5. It says, two forces 100 newtons and 60 newtons act on an object of mass 10 kg as illustrated in the diagram above. Neglecting friction, calculate the acceleration of the object. So guys, for this here, we are going to calculate for the vertical and horizontal components of the 100 newtons here, and that's because this component is actually inclined. In order for us to check out the vertical and horizontal components of the 100 newtons, we are going to do 100 sin 45. 45 is the angle here, angle 45 degree. So that's 70.71, And we're also going to do 100 cos 45, and that's also 70.71. So guys, now the vertical forces acting on this mass will be the 100 newtons minus 70.71. So, whereas the horizontal forces acting on this block will be the 70.71 plus this 60 newtons here. So now when we get these values, which are 29.29 and 130.71, we can now go ahead to calculate for the resultant force here. So in this case, we are actually going to have the resultant force to be equal to x squared plus y squared using the Pythagoras triangular formula. So in that case, x squared and y squared are actually 29.29 squared plus 130.71 squared. So z squared is equal to 29.29 squared plus 130.71 squared. So in that case, z alone is going to be the square root of this, and that's about 133.9. So guys, if we divide this value by the mass, then we'll get the acceleration, because force is actually mass times acceleration. So if we make acceleration the subject of this equation, that will be dividing the force by the mass. So let's recall that the mass here is 10 kg. So when we divide 133.9 by 10, we are going to have 13.39 thereabouts. So guys, the closest answer to this is option D here, which says 13.1 meter per second squared. So that's option D here, the answer to this question. Let's go ahead and consider the next question, guys. Alright guys, so the next question we have here is question number 6 here. It says, a block is acted upon by two horizontal forces as illustrated in the diagram above. The block accelerates at 1.5 meter per second squared. Calculate the mass of the block. So guys, for this question like this, we are going to have here that force is equal to mass times acceleration, like we all already know. So in order for us to calculate the mass of the block here, we are going to calculate the mass of the block using the equation by making the mass the subject of this equation, where mass becomes force over the acceleration. So if we do the force over the acceleration, we're going to have the net force here to be 10 newtons minus 1 newton, which is 9 newton, over the acceleration, which is 1.5. So guys, 9 over 1.5 will be 6 kilogram. So option B is the answer to this question. Let's go ahead and consider the next question, guys. Right, so guys, the next question here says, an 800 kilogram car moving at 80 kilometer per hour collides with a 1200 kilogram car moving at 40 kilometer per hour in the same direction. If the cars stick together, calculate their common velocity. So guys, if we use that m1u1 plus m2u2 is equal to m1v1 plus m2v2, we are going to have that, okay, since we are calculating for their common velocity, we are going to express this equation as m1u1 plus m2u2 is equal to m1 plus m2 all multiplied by v. So in that case, calculating for their common velocity will make v the subject of this equation, where v becomes m1u1 plus m2u2 over m1 plus m2. So guys, in that case, V is equal to 800 kg times 80 km/h, then plus 1200 kg times 40 km/h, then all over 800 kg plus 1200 kg. So guys, let's go ahead and calculate this. So guys, the answer to this question here will be 56 km/h, and that's option B here. So option B is the answer to this question. Let's go ahead and consider the next question, guys. So the next question here, question number 8, says the tendency of a body to remain at rest when a force is applied to it is called A. Friction, B. Inertia, C. Impulse, D. Momentum. So guys, the answer to this question is option B, that's inertia. So let's go ahead and consider the next question, guys. So the next question here is question number 9. It says a body of mass 20 kg is set in motion by two forces, 3 newtons and 4 newtons, acting at right angle to each other. Determine the magnitude of acceleration. So guys, for this here, first of all, we are going to get the resultant force here, and that will be z squared is equal to s squared plus y squared. So in that case, z squared is equal to 3 squared plus 4 squared, and that's 9 plus 16, and that's 25. So z alone is root 25, and that's 5. So the resultant force here is 5, guys. So if the resultant force here is 5 here, the acceleration will be the force over the mass. So that's 5 over 20, and that's 0.25. That's option C here, guys. Let's go ahead and consider the next and last question, guys. So guys, the next and last question we have here is question number 10. It says, when the linear momentum of a body is constant, the net force acting on it, A, remain constant, B, is 0, C, decreases, D, increases. So guys, the answer to this question is option B. When the linear momentum of a body is constant, the net force acting on it is 0. So that's it for this question. So guys, this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll be sure to give you a response.